Welcome to another video on my Raspberry Pi 1 running Raspbian Linux, connected to oscilloscope on the serial port, then a serial cable for data acquisition, a Raspberry Pi camera, RaspberryCam, on a fischertechnik stand for view via VLC. Also a network cable for VNC, virtual network computing, and a band cable that goes to this breadboard for using or controlling this part of the circuit. These two are not applicable right now. And with VNC I'm also connected to this Android tablet. Also connected via VNC to an Apple laptop, MacBook. This circuit has a fischertechnik light dependent resistor, an ordinary light dependent resistor, and the DC resistor for temperature. Chip is an MCP 3008, which goes via the serial peripheral interface protocol, hence 4 wires, for analog to digital conversion. And everything is programmed in Python for this project. The idea is that I get values obviously from the sensors, and then via scientific language Octave get also a data log with well, the components with the values. And also connected, depending on the value of LDR, to LEDs that go blinking. And after this introduction, let's go to the software side. And the software side, with VNC, virtual network computing on this one, RaspberryPi streaming, starting off the Pi scope, which doesn't do anything because the program isn't running yet. Then the software in Python, obviously running on the Raspberry Pi. Another view of the circuit, and this is via the Raspberry Pi with a few seconds delay. Oscilloscope set to SPI and RS232. So this is channel 4, this is channel 4, and that works out nicely. Let me see if I can get the image a little bit. Yeah, that's better. Now everything works kind of. In the end of last time, I had to make a few fixes, not in here, but rather in here, because I had to, when you copy parts of code, make sure you adapt them to the statement where you copy them to. So that works out. But what doesn't work out yet is that this is being printed. This what appeared to be some weird numbering is actually the number you see here when it starts running like now. So you see this number, which is the same as this number, which may appear very strangely, but it is correct. because this is the byte, but this is ASCII. So while this is readable, this isn't, and that's not the idea. So you read everything here with short peaks and pikes here, and everything does work. Here you see on the Pi scope as well, and let me take another look at the tablet. And I have to correct something because you are not looking at the Pi scope right now. So I have to drag it up, and now you can see the same thing, a little bit clearer, close by, and then you see a little light, I think. But anyway, those signals, and you can compare them with the signals above, and then you see that it is not at the exact same time. So that's a bit weird. And the question is, will this delay, or maybe even, yeah, I assume it is delay because it's wired, it's wireless, and it's slow because it's an old tablet. So I'm curious how this will be on the MacBook this time. I think no change, but who knows. The MacBook is of course wired. Well, not of course, but in my case. So let's run this, and well, no need to run because I know the problem, but why does it happen anyway? And I'll have to be right here somewhere. So here I assign everything that is read serially into the data, into this string. Then I assign everything in ASCII, because this is the conversion to from ASCII to from byte to ASCII, American Standard Code for Information Interchange. So this is all readable. Now what I can do, of course, is use this part, because now I'm looking at it again. I might have to change from data to data 2. And I think that might be my problem right now. Let me try this, because here I am comparing with data 2 and here I am using data. So what if I use this? That may just be the culprit. Let's check that out. If now in the data log here in LDR starts to get 3 digits, then I know that I'm correct. So let's run this and see. But let's see if the right again. Okay, I have to take ownership again of the USB port. Time it again, I forgot to check it, but why does it happen anyway? Why do I have to do it? I'd like to solve that one rather than which one I'm using. 1. So go reading line 46. What is the error again? 17 something with 120. Oh, that is the point. One row, 20 elements. Then what's the problem if I call 17? Or should I call 117? I don't think so, but let's try that. Would be a new insight somehow. So 117, 118, 119, no. 119 and 120. Okay, once again, go. Alright, that runs. And now the idea is that I get inside this datalog and have some changes of value. And of course I have to go here as well. Yeah, do I see some nice changes? And I have to touch this one as well. Alright. Oh, now I know why the LEDs aren't blinking. I ruined the connection. And that should be somewhere along the line here. Yeah, no, it has to blink. Alright, I have to find out which line it was. And now you see the big problem with an old board like the Raspberry Pi, because it's all very slow, slowly refreshing, etc. Seven, yeah, thought so. So right here I have to find pin 7 again. And that may just be this one. let's try again. Putting this up right. What values do I get? I did for LDR. Well, am I really wrong now? No, I'm not. It should work. Anyway, let's find the values. Point is that I first have to stop this one. Now I have to wait a little bit, but I can RPI FT, yeah. What's the date? What is the time? Time is alright. That means that I can see for it. And this is in no way what I expected. I expected to see a nice value for LDR. Alright, LDR1. I have to look for what LDR1 says. And LDR1 is empty. And LDR is empty. Wait, what does it do? LDR1 is empty, it says. Okay, then I will have to find out what the first character is. Display 17. Let's just put it like this, and then say data 2 117. I really want to know what this one is. Go. 17 is empty. 17 is absolutely empty. That is not what I intend. Why does this go wrong? Where does this go wrong? Right, something is getting weird now. I have now changed here a little bit in the Octave code, where I compare just LDR and I say, okay, what is the first of the 17 element of data? Then I do exactly the same here, but I do it here, which is basically exactly the same. So I assign, so basically I convert it to ASCII, and here I do exactly the same. But what happens here, oops, here now, empty. No, not empty. This says 10. What do you read here? LDR is 10. Then conversion to ASCII, empty. ASCII, empty. So whatever is happening doesn't make sense to me. So here I convert and here I convert. But what's the point? Where does it go wrong anyway? Alright, then I have to go back to data, publishing data. What is data anyway? So let's do that one. Few times and looking here. LDR2, these are just nice 3-digit values. And I have to look for data 2 is. Alright. Quit. Look for data 2. Empty. It's absolutely empty. Well, here data 2 is not empty. Here data 2 says NTC value. So that is correct. It actually is correct what it does. Let's find more. Except that LDR2 value is here quite corrupted. And data 2 here is resistor corrupted as well. Oh wait, am I doing something wrong here? Yeah, I'm doing something wrong. I have Minicom running and I shouldn't do that. Okay. That is what may have gone wrong. Do it again. Data 2 now gives real values. And now I have to watch for equal 1. So I help it a bit. Although that can't be done because it is what it is. Oh, right, I already noticed an instance. Right here, it says 50. 50 should be 2. Is 50 indeed 2? I have to find the answer in the ASCII table. That's a nice one. Let me check if that indeed is true. That LDR1 should be 255, which is quite logical if you look at this value, but I have to be sure. What I also can do now is, no, this is rubbish again. So yeah, let me take a look at the ASCII table. Alright, it turns out that indeed now I have 50 here, which is ASCII code for character 2, and here character 2 as well. So this is absolutely correct. And this says LDR is now 255. So this is loading a correct value. A very correct value. So this means that I would have to do a complete conversion to 2 and then 117. Because if this is working out, I would be quite happy. But then everything should be 2. Although this now gives the same data as this one. Using this one should be no problem. But then why should why do I use data 2? I use data 2, so let me use data 2. And that is data 2, 1, 17 again. And that's all of it. So this should be fine. Oh wait, I forgot one. Right, let's now run this and see if everything does go right. Because now that I have adapted all if statements, it should be in here. Let's go. That is to say, does it really go? Yeah, it does. Alright, and here. Let's play with the values a bit. Alright, and let's also take a look at this one. So really covering them up by dependent resistor, and I have the feeling that they both work the opposite way, although that is a bit strange, but who knows. And while holding them, a look at this one again. Which is still strangely acting compared to the other one. So let's also take a short look at the Mac, where I expect them to go together. So I'll let this run for a bit and let's go to the Mac. Alright, short look at the Mac, and if I look at both screens, you can't see them, I can, then they're not the same. because right now I see here TX and I still don't. Yeah, okay, again. No, there's a different time difference in them. So right now that's weird. The same signals, but they're not at the same time. No, definitely a difference. And which one is faster or slower than the other? That is hard to say. Maybe let's see about the timing. So I go here for a moment, and this is say 2913, and this is way ahead of it. But that's probably the time that I have been running those. So no, they are definitely not giving the same information at the same time. Right, weird to see, but that's the way it is, apparently. So, it's been running a while, and let's now take a look at how this looks like. Which I can't because it's still running. Now I interrupt it. I have to look at the time, 10:10, alright. Yeah, that's not really what I was expecting. Maybe a little bit more time. So, going back to PiScope, and yeah, which have been gone under. This is always giving the correct signal, of course, and this is very condensed. But the fact that both a tablet and the Mac give different responses than what I can actually see on the Mac, not on the Mac but on the Raspberry Pi. That is quite weird. Right, last attempt to watch this one. Is so not working out. This is really not working out. No. Not a chance. I don't know what the problem is, but I do know that if I look back here, this is good, and then resistor is 0, probably. LDR value 223. Is that correct? I'm not quite sure. Oh wait, yeah, because I only did this here, not here. So since this is going showing that this is correct, then I would have expected that this would work through. it hasn't. That's the only conclusion I can draw now. It hasn't worked through in datalog. Ouch. Anyway, more than time to wrap up. And that is the end of this video with some weird behavior with the Pi scope. Good behavior, of course, of the normal oscilloscope. And some weird stuff with Octave. Why does it work that way? Values finally catching right, but going wrong in the end. Anyway, again, good reason to continue. Thanks for watching this video. If you like it, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. What am I doing wrong? Maybe. You can also follow me via Instagram and Twitter. Please consider a donation via PayPal or Wired. And you can also become a patron. And depending on the pledge you make, have your name mentioned on my website and videos. For now, to be continued. Have a nice day. Take a look at the description box on this video for more information, and bye bye.